to S Chemistry. I'm your instructor Dr. Suhas Gaudi. I'm going to take talk on BSc 5th semester Physical Chemistry course on elementary quantum mechanics. So here is the outline. First, I will go through Rutherford model of the atom, followed by Bohr's atomic model of atomic structure. Let's see what's Rutherford's model of the atom. As we know, electron revolves around the nucleus in such a way that Coulombic attraction of the electron by the nucleus is balanced by centrifugal force. So here, electron revolve around the circular pathway around the nucleus, and the velocity that is tangential to the circular path. So this is the direction of the motion of electron. So as we know, Coulombic attraction between two opposite charge, that is electron and proton, which is located in the nucleus. So attraction force we call it centripetal force. Also we call it Coulombic attraction. So and that is balanced by centrifugal force, which is going to be outward in the direction. So let's see what is Coulombic attraction. So the force of attraction between oppositely charged particle, that is plus proton and minus electron. So this force is equal to the K into Q1 into Q2 divided by R square. So R is the distance between two opposite charge particle Q1 and Q2, where Q1 and Q2 are the mass of the particles and K is the constant. So now if you equate the Coulombic force, that is equal to the centrifugal force. So where in this equation the K is 1 by 4 pi epsilon naught, that is the K value, and Z is the neutron proton charge, and E is the electron mass divided by R square, and that is equal to the mv square divided by R. So this is the centrifugal force and this is the Coulombic force. Now we will see the whole model of atomic structure. First we will see postulate. So first postulate says the electron in an atom can revolve around the nucleus only in certain allowed circular orbits without losing any energy. So as we know, electron revolves. So for every atom there is the electron configuration. So each uh, electron configuration is related to the particular energy. So that's why the electron in an atom is revolve around the nucleus only in a certain allowed circular orbits. So it always continuously revolving, that is revolving due to Coulombic attraction, that is without losing any energy. So that is the first postulate. So second postulate is the electron revolve around the nucleus, that is a stationary state exists for the atom when it does not emit radiation, so violating the classical electromagnetic theory. So here, as we know, the electron revolve around the nucleus, so it is a fixed path and it is continuously going like infinite for the infinite time. So that is we call it a stationary state. So this state is exist for only in atom. So when it does not emit a radiation, uh, that is the violating the classical electromagnetic theory. Now, third postulate is the orbit of electronic motions are circular and well defined, are such that the angular momentum, that is mvr, where m is the mass, v is the velocity, and r is the radial distance of the electron is quantized in units of pi h by 2 pi. So that is mvr equal to nth for the nth orbit, that is n into h by 2 pi. So where n can be any integer number, that is 1, 2, 3 and so on. So further this equation can be written as h cross. So MVR equal to NH bar. So here H bar is nothing but the H by 2 pi, where mass m equal to mass of electron, v equal to velocity of electron, L is the orbital angular momentum of the electron, and n equal to a number of orbit. So as we go on increasing the number of orbit, so your n will also change and corresponding uh, energy also will change, that is angular momentum. So postulate 4 says that the electron can jump from one of the allowed orbits to another. So whenever it's jump of electron if one orbit to another orbit, so there is either absorption or emission of the radiations. So when atoms emits the radiation, so atom radiate emissions when an electron undergoes transition from one stationary state to another state of lower energy. So this is very important. So electron should jump from one stationary state to another state of lower energy. So that time it will emit the radiation. And when will atom absorb? So atom absorb when the electron undergoes transition from one stationary state to another state of higher energy stationary state. So that time it will absorb the energy. So as you can see in this figure, so whenever the energy get absorbed, that is photon energy, it's a bundle of energy h nu. So it is jump from lower state to higher state, that is excited state. That time it absorbs the energy, it goes to higher state. So delta E is equal to h nu. So as you can see, the below state is lower state is the ground state. So when it emits the whenever the energy excited state to transition from excited state to the ground state, that time atoms radiates or emits the radiation, that is h nu. Now postulate says that this h nu, that is equal to the delta E, that is equal to E final minus E initial. So here EF means E final and minus I means initial of energy, initial state of energy. So where n equal NF is always greater, here NF is greater than the NI. So initial orbit is final orbit is a bigger number and initial orbit is a lower number. So that time this equation is valid. So this equation is known as the Bohr frequency condition. So this is the Bohr frequency condition where En is equal to minus mass of electron, that is Me, electron mass E to the power 4 divided by 8 pi epsilon naught square h square into n square. So if you take out this, if you apply this equation over here, if you put this equation over here, you will get delta E equal to Me e to the power 4 divided by 4 pi 8 pi epsilon naught square h square. So here in bracket you take it common as a 1 by n1 square minus 1 by n2 square. So the difference will come, that is h nu, where n2 is greater than n1. Setting delta E equal to h nu is called the Bohr frequency condition. So the spectral series for hydrogen atom, where nu bar is equal to Me to the power e to the power 4 divided by 8 pi epsilon naught square h cube into c. So here this equation is divided by c, so it comes in frequency range. So wave number. So into this equation into 1 by n1 square minus 1 by n2 square. So what happens? It will come as this whole term we consider as an RH, that is also known as a Rydberg constant. So remaining equation will be the same. So the where RH value of RH is equal to 10,000 1 lakh 9,737 centimeter inverse. So this is a 5-digit number, so you have to memorize. So the Lemon series occurred when electrons that are excited to higher levels relax to n equal to 1 state. So where n equal to 2 value comes, that is we call it Balmer series, that is a visible range. So in this series what happens when electrons that excite to higher energy levels and that is relaxed to the n equal to 2 state. So that time Balmer series will come. That come this whatever the radiation comes, that is visible range. When n equal to 3, we call it Bastian series. This series comes in IR region. When n equal to 4, that comes is a bracket series. That is also comes in IR region. Now we will see the radius of stationary orbits. As you can see here, r equal to n square h square into 4 pi epsilon naught divided by 4 pi square m z e square. So this equation is equal to n square divided by z a naught, where a naught is equal to h square 4 pi epsilon naught divided by 4 pi square m e square. So that is the radius, Bohr radius. So this equation we can rewrite as a h bar h bar square into 4 pi epsilon naught divided by m e square. So where a naught is the Bohr radius. So this comes due to h by 2 pi. H bar is equal to h by 2 pi. If you square this h bar square, so you will get this term as it is. Now, what are the defects of Bohr model? So that we will see here. So Bohr model only account for the spectral lines for the hydrogen atom or hydrogenic species, where your outermost or first orbit contains only one electron. So this is the defects of the Bohr model. So species containing only one electron, such as helium plus and lithium 2 plus. So that is lithium ions. So second condition is second defect of Bohr model is, so Bohr theory provides no explanation for the relative intensity of the various spectral lines. So there is no explanation in the Bohr theory. So third point says that no explanation for the splitting of spectral lines into many lines in the presence of magnetic field. So we also call this effect is a Zeeman effect, and electric field we call it Stark effects. So there is always will be the splitting, that splitting of spectral lines into many lines in the presence of magnetic field as well as in electric field. So there is no explanation in Bohr atomic theory. So this is a defect. So fourth defect is, in Bohr theory there is no place for the wave character of the electron. So that is only particle character only. So fifth defect is, the second objection was raised by Heisenberg uncertainty principle, which said that it is impossible to evaluate the precise position and momentum of the electron simultaneously. So as we know Heisenberg uncertainty principle, so it is impossible to evaluate the precise position and the momentum of the electron. So we cannot simultaneously talk about position as well as momentum. Thank you.